Okay, this is video 3, the last video in the series. Previously, we learned about that these rivets all follow a set of standards, right? That was the ASME, SAE stuff. Okay. Knowing that they all have the standards, each company that manufactures or distributes a rivet follows those guidelines. They all have a different part number. And like I said, we're all used to the CCP 42s and CCP 46s because that's Cherry Company, okay? So in a stainless rivet, well, let's just say any rivet, there's going to be two things that we need to consider in this project. Shear strength, tensile strength, okay? And again, these standards are all figured out for us, okay? If you were to look at tensile strength, okay, let's just say that this is a gusset, this is a tube, this is a rivet. Tensile strength is kind of like pulling it apart, the ability to handle that load, that direction. If we were to talk about shear strength, it's the ability of that fastener, in our case a rivet, this direction, okay? Those are the two loads that are imposed on the empennage of the Legal Eagle aircraft tail that we need to consider, okay? Aluminum, although it could work, I don't really know what people are using, honestly, for rivets. I personally would not use an aluminum rivet, just based on, well, based on the loads, based on the ability of an aluminum rivet to handle shear strength and tensile strength. So I am going to go with stainless steel. Now, this is a chart. I know it's kind of hard to see. This, again, here it lists SAE J1200. And we go back here, SAE J1200, right? That has to do with the dimensions and mechanical and the standards, everything about those rivets. That's the section, okay? And here's a set of standards. Now, they give all these dimensions, but let's take a look at ultimate shear load, ultimate tensile load, okay? We're going to use an 1/8 inch rivet, okay? The minimum pounds per square inch of ultimate shear load is 420. The ultimate tensile, okay, is 530. So if we go back to all these rivets, these companies that make them, Cherry, I'm using Marson, a lot of people use Cherry, okay, they have to meet these standards at a minimum. And you look down here, it talks about material, right? Rivet and stainless, 305 or equivalent, stainless steel. The mandrel, stainless steel, 300 series of stainless, okay? Talks a little bit about the shear strength, tensile strength. These are minimums in this table, okay? Now I'm going to show you something kind of unique. Here is, now remember we looked at, this is Cherry Aerospace. This is Cherry's numbers. This is their specs for the numbers. So a CC42, okay, 1/8 inch diameter, 225 thousandths length, which is, let me just grab this. That's the length of this aluminum body right here, okay. Grip range. So how thick a material, if you were to bundle this material together, there's a grip range, 63 thousandths to 125. Now, that is a set of numbers that the engineers calculated that if they're going to give these shear loads and tensile loads and all of this information on engineering, they had to pick a grip range that will work for, okay? Now, it's interesting, if you look at a CC42, which is used in a Sonics, let's see, in their wing, I think their skin is 25 thousandths, and I think the rib is 25 thousandths. It could be 20. Either way, let's just say it's 50 thousandths. Well, that's smaller than the range. Now, isn't that interesting? So, in theory, the ultimate shear load and ultimate tensile load is not quite going to be ideal. Now, that's not a bad thing, but it's something to take into consideration. Now, I'm going to show you something that's pretty cool. This is a Marson. This is, okay, in other words, this is the same rivet. This is Cherry's version. This is Marson's version. Fastenal sells Marson. Okay, they sell others, but Marson's a big one. Now, if you look at the shear strength of a Marson rivet, which is the equivalent of that CCP 42, okay, Marson's version is an SSP 4-2S. The shear strength is 520 pounds per square inch. Tensile strength is 600 pounds per square inch. Let's review. Okay. Look at this. Cherry rivet, or the CCP 42, shear 450. Marson, shear 520. Okay, tensile 600, tensile 600. So the Marson has a higher shear strength in that grip range. Let's look at the grip range. Again, 0.63, 125, 0.63, 125. You see, this again, this goes back to those part numbers and these set of standards, right? Again, it's these standards, right? These engineers have calculated all this stuff out. So, with that said, now, again, we're going back to that Sonics, right? Well, could we use a CCP 42? That's the ultimate question here. Could we use a CCP 42, okay, to rivet everything in the Legal Eagle? Yeah, you probably could, okay? I'm not going to, but you could. So, let's look at our range. 55 thousandths. That channel is 20, so that's 40 thousandths total, okay? And then that tube is 93, and don't forget the hinge, okay? So, that's our range. Well, 63 to 125. So this 55, that's under the range. This is way under 40 thousandths. It's less than ideal. So again, I just want to repeat this, that this engineering table, okay, in order to obtain this guarantee, these certifications, they have to pick a range that that rivet can fasten. If you adhere to that range, they're going to guarantee the ultimate shear load and ultimate tensile load of that rivet. Okay. Now, for all practical reasons, a CCP 42 rivet, which again, this falls out of that range. It's not in that range. Okay. It will work. It's fine. I'm going to use something kind of different. Okay. Now, I think I showed you this Marson. Okay. So this has a grip range, 1/64 to 1/16. This, if we go back to the chart, oh, I know where it is. There we go. This is the rivet I'm going to use, okay? This is the equivalent of a Cherry CCP 41, which pretty much is not available at Aircraft Spruce or Wix. It's just shorter. That's all it is. It's identical, except it's just a little bit shorter. But the grip range is 20 thousandths to 62 thousandths. Okay, let's look at this now. So grip range, 20 to 62. Well, 40 thousandths fits right in there. Okay, so we know that every time we bend that 20 thousandths channel, this small, that small rivet's going to work. Okay, 55 thousandths falls right in. Okay, this does not fall in. So I'm going to actually use CCP 42 class rivet. I'm going to still use Marson because I feel it's a strong rivet. So if you look here, and here we go to that specification, right? That ASME number. See, it's all the same. They all follow those rules. So that's pretty much it on these rivets. I'm going to use a stainless steel rivet. I'm going to use, okay, a stainless mandrel here, stainless body, a protruding head, okay. So I'm calling them a button head, protruding head. Protruding head is a very standard rivet. I mean, there's nothing complex about this rivet. They're used everywhere. I'm going to stick with stainless, like I said. I'm going to use a Marson, okay. And for most of the project that falls into that grip range, I'm going to use this Marson SSB4-1S. Okay. When I go to the thicker stuff, I'm not going to use the Cherry. I'm going to use a Marson SSB4-2S. It's a little longer. Okay. That's it. Do your own homework. Do your own math. Understand the problem. Don't get frustrated. The plans are complete. Follow what successful people have done in the past, and that is they learn, they educate, and they practice. So that's it. Have a good one, guys.